see Lindelof videos, more mixed chain rule problems. This one is y is equal to x over the square root of x squared plus 1, and we're asked to find y prime. I'm getting this question over and over from you guys, and I get it. And the only way I can kind of explain this to you is through going through a problem. I get from you, how am I supposed to know this is a chain rule problem? Well, you're kind of not initially supposed to get it. However, you start to look at this, you're like, okay, to me this looks like a quotient. It looks most obviously like a quotient rule problem. So that's what I'm going to do. I'm going to say to myself, I'm going to set up the quotient rule here. And I know for the quotient rule, I need f of x is the top, g of x is the bottom. So let's say f of x is equal to x. F prime at x, well, of course, the first derivative of x is 1. And then g of x, I'm going to rewrite it a tiny bit. It's just this bottom portion, right? So it's the square root of this whole thing, right? And I'm going to rewrite the square root, if you don't mind. I'm going to rewrite square root as 1/2 power, right? Of x squared plus 1. Now, the next thing I need is g prime at x. I need to know what the derivative of this is. This is where, hopefully, you're looking, you're like, dude, how do I take this derivative? And hopefully you see that in blue, here's this outer shell piece. There's this outside function piece in blue. And then there's an inside function piece. So there's the chain rule part. And what you're going to do is you're going to use the chain rule to gather something that you need, in this case, for the quotient rule. So I'm going to just start to take the derivative. The derivative of the outside, that is the piece in blue, is 1/2, that thing in gray, to the negative 1/2 power. How did I get negative 1/2? I did 1/2 minus 1, and 1/2 minus 1 is negative 1/2, isn't it? And then I'm going to go back and say, okay, well, I have to put in my inside function. But what's the derivative of the inside function? Well, the derivative of x squared plus 1 is 2x. So what you just did was you just used the chain rule to provide yourself the piece that you needed for the quotient rule, right? I am going to simplify this out a little bit. I'm going to start cleaning this up. I'm going to do 1/2 times 2x, and 1/2 times 2 is 1, and 1 times x is x. So if you don't mind, I'm going to just move this x to the front. Hope that makes perfect sense to you. So there's that. And now I'm going to start building my quotient rule. And if you remember, the quotient rule, right, d dx of a function over another function is equal to the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. Isn't that true? So why did I do all this list crap? Because I need to substitute these pieces, and I have it. I have g of x here, and look, here's that g prime at x thing. I had to use the chain rule to gather that piece that I needed. So all I was doing was gathering pieces. And now I'm going to start to put this together, and I know that g of x is equal to x squared plus 1 to the 1/2 power. I know I'm going to multiply by the derivative of f, and the derivative of f is 1, so that one is this one, minus, and then f of x was just equal to x, wasn't it? Times the derivative of the inside, and the derivative of the inside, that was the thing we spent time on, was x times, and if you don't mind, because this is a negative exponent, I'm going to go ahead and change this up and put this as 1 over x squared plus 1. Hopefully you can see why I did that to the 1/2 power. Doing this, I just was getting rid of this negative exponent here, right? And then remember, it was all over g of x squared. So g of x is x squared plus 1 to the 1/2 power. But I'm going to square that, and when I square that, these two things cancel each other out, don't they? So I just get this mess here, don't I? Now, I'm not telling you that this process is easy, because we're not done yet. So this is a pain in the neck, but we're getting there. I'm going to clean this up, and I'm going to say x squared plus 1 to the 1/2 power times 1 is just the same thing, which is x squared plus 1 to the 1/2 power minus, and then x times x is x squared, and x squared times this 1 up here is this negative x squared, isn't it? All over x squared plus 1 to the 1/2 power, all over, good gracious, it's a lot, isn't it? Right? And I'm still fishing for my derivative. Now hopefully what you're recognizing here is that this is theorem of complex fractions, so this is a complex fraction. So I'm going to start cleaning this up. I want to add this piece and this one, in this case subtract them, but I don't have a common denominator. So the common denominator, this is over 1, isn't it? So the common denominator will be x squared plus 1 to the 1/2 power. I have to multiply that over itself, because I'm going to multiply by 1, right? 1/2 power. Now, this thing, believe it or not, is starting to clean up pretty good. Because this is x squared plus 1 is this factor here, and so is this one, then when we multiply this times this, we just add their exponential values, and 1/2 plus 1/2 is 1. So we get x squared plus 1 to the first power, which is just x squared plus 1, minus x squared, right? All over, and now we have this common denominator, which is x squared plus 1 to the 1/2 power, holy macaroni, all over x squared plus 1. This x squared plus 1, you guys, is this one right here, isn't it? Just cleaning this joint up a little bit. Now I have theorem of complex fractions, which says if I have a fraction over a fraction, I take the fraction in the numerator multiplied by the reciprocal of the fraction in the denominator. So that will look like this. Well, actually, I can clean. Oh my God, I can clean this up too. Look, there's a positive x squared here and a negative x squared. That cleans up really nicely. That's sweet. Cool. So I'm going to do 1 over x squared plus 1 to the 1/2 power times this 1 right here. Remember, taking the reciprocal, so this goes to the top. So this 1 is this one. This thing comes down to the denominator, so x squared plus 1. Think about this. This is right, and this is to the first power, otherwise known as the 2/2 power, isn't it? Wow, almost there. 1 times 1 is 1. I have x squared plus 1 to the 1/2 times x squared plus 1 to the 2/2, which is x squared plus 1 to the 3/2. If you want to, you can write that as 1 over x squared plus 1 square root, right? Because look at this for a second. Because in in a rational exponent, the bottom number is the root, so this 2 gives me this square root here, doesn't it? And then what I think I'm going to do is this. I'm going to do it this way, I think. This is the power, so I'm going to do this and put it to the 3rd power. And that, my friends, is my answer. So, this is a lot, man. I really know this is a lot. So just remember, when you're looking, first decide what general rule you're going to use. And I decided to use the quotient rule. Make your list of the parts that you need for the rule that you're going to use. And then you may discover, as we did here at g of x, that to get the derivative here, we have to use the chain rule. All right? Look, I hope this was really helpful, and I know this is tough. You can definitely do this. If you have any comments, please make them. And if you haven't already subscribed, please do. Thanks.